Question number 18 on the worksheet on forces on inclined plane. A particle of mass 12 kg is stationary on a rough inclined plane at an angle of 25 degree. Let's quickly make this. So 25 degree, and there's a particle and its mass is 12 kg. So I'm going to resolve its forces mg. So 120 cos 25. And the one down the slope would be mg sine 25. This would be R, the normal contact force. A force of magnitude P Newton acting parallel to the line of greatest slope of the plane is used to prevent the particle from sliding down. The coefficient of friction between the particle and the plane is this. This is the value of mu. Draw the sketch showing the forces acting on the plane. Okay, and uh, P Newton would be in this direction since it's stopping it from falling downwards. Okay, so we have to draw a sketch showing all the forces. Now, in the marking scheme, the sketch does not show the components of the weight. It just shows the weight. So if this is the particle, weight is directly pointing downwards, and this is mg. So it's going to be 120 Newton here. R is shown normal to the contact. So here, then let's just make them originate from the same point. So let's say here, this would be normal to the contact. P is in this direction, and no need to write the components of weight. And we have to mention the friction. Now, the question so far is silent about whether this particle will go upwards or downwards. So friction can be drawn on either side. So we know there's a mg sine theta here and mg cos theta here, but it's not required to be drawn. Okay, components are not required to be drawn. Okay, and now we don't know if the friction will be towards the upper side or towards the lower side. So the marking scheme accepted both the working. So you could draw mu r friction, and friction is represented by F here, or you may not show any force here and draw the friction here. So we don't know if it's upwards or downwards yet, so we can draw it on either side. Okay, part A is done. Part B says find the least possible value of P. Okay, now it matters whether the friction is going to be upwards or downwards. Okay, so if we need the least possible value of P, let's say the friction, I'm going to assume that the friction is in this direction. Would this give the least possible value of P? Let's see, P will be equals to 120 sine 25 plus mu times r. Okay, so something is being added to 120 sine 45, sine 25. And what if the mu is in the opposite direction? Okay, this is 25. Okay, what if mu is in this direction? Okay, then that would mean that we get the equation 120 sine 25 is equals to mu r plus P, which means P is equals to 120 sine 25 minus mu r. So we can see that this one will give us a smaller value of P. So let's stick to this working where the friction would be acting upwards. So then the value of P will be smaller as compared to when the friction is acting down the plane. Okay, so let's find out the values. We have 120 sine 25 and we have mu 0.35 and R is equals to this 120 cos 25 and this should be equals to P, which gives us 12.6. After rounding 6492 rounds to 12.6 newtons.